for x in 0 to 1 and s greater than 0, consider the family e to the negative s absolute value log x. So these functions satisfy the scaling p to e with generator L defined to be partial x, and the PDE is the following: s partial s sx equals negative L by s of x. All right, so these functions also are rapidly decaying as x to 0. So now we define what's called the Mellon transform. Define the Mellon transform to be this x to the r phi sx dx over x. All right, the integral can be computed, and it turns out that it equals this, where k is the Bessel k, modified Bessel k function of the second kind. And this kernel is standard radial Green's function for a two-dimensional cone. Then we take a second dual family, and this corresponds to a flattened cone apex at x equals 1. And after a Mellon transform, the resulting spectral kernel agrees up to a change of variables with this. So the Mellon transform localizes at the cone apexes and does not retain info about whether the cone originated at x equals 0 or x equals 1. We then define some involutions and go on to define the symmetry group, which is isomorphic to the Klein 4